Assalamualaikum and good afternoon to Dr. Ramani and to all my friends. My name is Nurkarun Sofia binti Azahari. Today, me and my teammates from Group 8 will be presenting the topic about deep learning. I'm delighted to present this topic alongside with my talented team members, Rashika Anapurpa Balichandran, Ronald Aaron Soria, Muhammad Haris bin Abdullah, and Muhammad Iskandar bin Muhammad Shah. Our topic for presentation today will cover three main topics, which are the history of deep learning, the achievement of deep learning, and the Culloch Pitts Neuron. So without further ado, let's go to the first slide, which is what is deep learning? What is the definition behind it? So deep learning is a subset, or we call it as a portion of machine learning, which in turn is also a portion of artificial intelligence, or in a short form, we call it AI. So as you know, the definition of artificial intelligence, or AI, is a technique that enables a machine to mimic like a human behavior. Mimic human behavior meaning that the system or a machine able to act like a human and think like a human. The next one is the machine learning. Machine learning is a technique to achieve AI through algorithm trained with a data set. And finally is the deep learning. The deep learning is a type of machine learning inspired by the structure of the human brain. And this structure is known as artificial neural network. So the next one is the deep learning versus machine learning. So let's understand the deep learning better and how it is different from the machine learning. Let's take for an example. As you can see, there's one machine in the slides that could be used to differentiate between tomatoes and cherries. And by using machine learning, we have to tell to the machine the feature based on which the two can be differentiated. It could be the size and the type of stem on them. As for the deep learning, it consists of multiple layers of interconnected nodes, or we call it neurons, and each layer learns progressively more abstract and complex feature from the raw data. The neural network automatically extracts the only relevant feature from the data during the training process. On the other hand, with the deep learning, the features are picked out by the neural network without human intervention. This is happened due to having much higher volume of data to train the machine. Let's move on to the timeline of where the deep learning started. So the timeline highlights the key milestone in the history of deep learning and the breakthrough that have shaped the field and its widespread adoption and impact in modern AI applications. In the 1943 was where the Warren McCulloch and Walter Pitts created a computer model based on the neural networks of the human brain. Towards between 1957 until 1962, the perception was developed by Frank Rosenblatt. It was one of the earliest forms of artificial neural networks, and the definition of perceptron is it is a mathematical model inspired by the way neurons work in the human brain, and it was designed to learn and make decisions based on the input features. Then 1986, the backpropagation algorithm was introduced by Geoffrey Hinton, David Rumelhart, and Ronald Williams, which made the training multi-layer neural network more efficient and practical. From 2012 until 2015, deep learning gained significant attention and achieved great results in various domains, such as image and speech recognition, autonomous driving, and more. And from 2018 until present time, OpenAI's GPT was released in 2018 and was superior to other existing language model at the time for problems like reading comprehension, common sense, and reasoning. The deep learning continues to advance rapidly, and it is being applied in various industries such as healthcare, finance, robotics, and more. So that's all from the history of deep learning from me. Now I will pass the presentation to Rashika to dive into the application of deep learning.
Thank you, Sophia. So now I'll be explaining about the application of deep learning in AI. Deep learning has a wide range of application across various industries. It is used for tasks like computer vision, natural language processing, speech recognition and generation, recommendation system, gaming, financial system, autonomous vehicle system, and as well as healthcare system. So now, to narrow down our aspects, I'll be explaining about certain deep learning success story based on how this aspect has been transformed in the industrial area. Starting off with the healthcare sector, which has led remarkable advancement in medical diagnosis, drug discovery, as well as personalized medicine. Let's begin with the medical imaging analysis. Deep learning model is known to improve disease diagnosis from medical imaging by learning its complex pattern and achieving remarkable accuracies. For an example, as picture 1 illustrates, deep learning algorithm has demonstrated exceptional performance in detecting breast cancers from mammograms. This advancement has not only aided radiologists in early detections but also have contributed to improve the treatments planning and also patients' outcome. Moving on to disease diagnosis, by analyzing the wide range of patients' data, deep learning models can identify the pattern and predict the disease risk. This has proven particularly effective in conditions such as diabetic retinopathy, where deep learning models can analyze retinal images and provide accurate diagnosis, enabling time interventions and also preventing potential complications to the patient itself. Next, deep learning accelerates drugs discovery by effectively screening chemical compounds for potential drugs. By analyzing intensive datasets of chemical structures, deep learning models can narrow down the search space, allowing researchers to prioritize the most promising drugs candidates for the future exploration. Lastly, deep learning has also paved the way for personalized medicines. For instance, deep learning models has been developed to predict cancer treatment outcome based on genome data. This enables oncologists to tailor therapies to each patient's unique characteristic, leading them to a more targeted and an effective way of treatment. Moving on to the next success story of deep learning would be speech recognition. Let's begin with voice assistants. Deep learning algorithms power voice assistants such as Siri, Google Assistant, Alexa, and this enables them to accurately recognize and also interpret speech, making them more intuitive and user-friendly to the users. Moving on to the next point, which is speech-to-text application. Deep learning models have greatly improved speech recognition's accuracy, in the term where deep learning models can accurately transcribe speech even in a noisy environment or in a diverse accent, improving the accessibility and the efficiency to various industry and also users. Lastly, NLP algorithm powered by deep learning enables machine to understand and generate human language naturally. Deep learning models in speech recognitions incorporate NLP techniques to understand the context, sentiment, and the intentions of the user, leading it to a more sophisticated and a human-like interactions between one another.
Now I will talk about deep learning success in autonomous vehicle and virtual assistant. The first one is autonomous vehicle. Perceptual capabilities. Deep learning models such as convolutional neural networks excel at visual perception. Thus, they can accurately analyze sensor data from cameras, lidar, and radar, allowing autonomous vehicles to understand and interpret their surroundings. By leveraging deep learning technique, autonomous vehicle can identify and classify objects, detect lane markings, and perceive complex scenes, also enabling safer navigation. The second one is sensor fusion. Autonomous vehicles employ multiple sensors, including cameras, lidar, radar, and GPS, to gather a comprehensive view of the environment. Deep learning models facilitate sensor fusion, enabling the integration and interpretation of data from different sensors. By combining information from multiple sources, autonomous vehicle can create a more accurate and robust representation of the surrounding world, improving their perception and decision-making capabilities. The next one is about deep learning success in virtual assistant. The first one is contextual understanding. Deep learning models can capture and understand contextual information, enabling virtual assistant to provide personalized and relevant responses based on the user query and specific context. This contextual understanding enhances the user experience by tailoring the assistant responses to individual preference and providing more accurate, useful information. The second one is user feedback and improvement. Virtual assistant leverage user feedback and data to improve their performance. Deep learning models can incorporate feedback and update their responses based on user interaction, allowing virtual assistant to continuously improve their understanding, language generation, and overall performance over time. Now I will pass to Harit for the next slide.
Thank you, Iskandar. Before we begin, let's understand what Culloch Pitts, short for MP neurons, are. It was created by Warren McCulloch and Walter Pitts in the 1940s as a simulation model to mimic the behavior of biological neurons, using simple binary of zeros and ones. They bring forth the foundation into the field of artificial neural networks, ANN, which has revolutionized AI. The structure of these MP neurons is quite straightforward. It first collects inputs from multiple sources, represented as binary values, and these binary inputs are combined together to produce an output. From this output summation, it will be compared with a fixed threshold value that will signify if the neuron should output a 1 or a 0. Think of it as a filter for the datasets. If the summation meets the threshold requirement, it will output a signal value of 1, and if it doesn't, it will output a 0. This can be done through the help of Boolean logic gates such as AND, OR, and NOT. Let's start with an example to understand further. So there are two inputs entering the neurons, x1 and x2, and the threshold value is that it must be equal or greater than 2. So we first draw the truth table, and we sum x1 and x2 of each row and compare it with the threshold value of 2. So if it is 2 or greater than 2, then it will output 1. As you can see, only when x1 and x2 is both 1 will meet the neuron's condition, hence output a 1 in that row. That is basically an AND gate. We can also increase the number of input and change the threshold value to meet a new condition. In this case, we have 3 inputs and require the sum to be greater or equal to 1. Thus, the output produced is similar to an OR gate. With this output, we can draw a geometric plane signifying the input's coordinates when the output is true. Now, let's say we change a bit. We only want one input that is true. We have to change the threshold condition to only accept a summation of equal to 1, not greater and not lesser. So you can see that the outputs trigger when only one input is true. I hope you all understand how it works now. As I said earlier, this Culloch Pitts neuron was developed during the 1940s, so more models are created following this MP neuron structure, contributing more into the advancement of AI. For instance, the perceptron. It was created roughly 10 years after the MP neurons was developed, showing significant improvement by adding weights into the structure. This allows the perceptron to adapt and make predictions based on new or unseen data. This is known as supervised learning. I will now pass to my good friend Ronald for his presentation on how this model can be used in real-life scenarios.
Thanks, Harit, for the sharing. Good morning and greetings to everyone. Today, we'll discuss on how a bank can make loan sanctioning decisions using two key parameters, which is salary and credit score. Let's dive in. To begin, we have two parameters to consider, which are salary and credit score. We represent them using binary values. A high salary is denoted as x1 equals to 1, while a low salary is represented as x1 equals to 0. Similarly, a good credit score is x2 equals to 1, and a bad credit score is x2 equals to 0. Now, let's explore the possible loan sanctioning scenarios based on the binary values we defined. As you can see from the slides, high salary and good credit score is defined with the binary values of both ones. The next one, high salary and bad credit score, is defined as 1 to 0. Low salary and good credit score is defined as 0 to 1. And the last one is low salary and bad credit score is defined as both zeros. Now, let's dive into the modeling of Culloch Pitts MP neuron, which can help us make loan sanctioning decisions based on the binary inputs of salary and credit score. The MP neuron model operates on binary threshold concept. It compares the activation potential to a predefined threshold to determine the output. For our loan sanctioning decision, we set the threshold value at 2. This means that an activation potential greater than or equal to 2 will result in loan sanction, while anything below 2 will lead to a loan not being sanctioned. We use binary inputs x and 1 to represent salary and credit score, respectively. The MP neuron takes these binary inputs and produces a binary output of 0, indicating whether the loan should be sanctioned 1 or not 0. To determine the output O, we calculate the net activation potential by summing the weighted inputs. If the activation potential is greater than or equal to the threshold delta, the output is set to 1, indicating loan sanction. If the net activation potential is below the threshold, the output is set to 0, indicating no loan sanction. Here is the computational ability of the MP neuron by analyzing one of the possible scenarios to be considered in sanctioning a loan. This is the example for high salary and good credit score. where the inputs both x1 and x2 is denoted as 1. So the activation potential is by adding both inputs where we obtain 2 as its value. As for the decision, since the activation potential 2 is greater than or equal to the threshold value of 2, the loan can be sanctioned. And the output O equals to 1, meaning loan is sanctioned. Here is the overall possibilities in sanction a loan based on salary and credit score. With the truth table for loan approved based on the 4 scenarios mentioned, the loan is approved only if the salary is high and credit score is good. Here is the slide that discusses on the limitation of MP neuron models. The Culloch Pitts, short formed as MP neuron model, is based on binary inputs and outputs. This limitation restricts its ability to handle continuous or multidimensional data. As an example, it has a restriction in handling continuous variables or working with complex data structures. In the MP neuron model, all inputs are assigned with equal weights. This assumption implies that all inputs contribute equally to the output of the neuron, where it follows strictly by its threshold value wholly. As an example, it is prioritized certain inputs or capturing varying degrees of significance. Nonlinear separability. The MP neuron model assumes linear separability of data. Linear separability means that the data can be classified by a single straight line or hyperplane. This assumption limits the model's effectiveness in handling problems with nonlinear separability. As an example, the XOR function or problems require nonlinear decision boundaries. Now, despite the limitations mentioned, the MP neuron model served as a foundation for future advancement in neural networks. More advanced models such as the perceptrons mentioned previously are the foundation for neural network learning such as the multi-layer perceptrons, MLPs, and convolutional neural networks, CNNs, to address these limitations. MLPs can handle non-Boolean inputs, assign different weights to inputs, and capture non-linear relationships. We have reached the final phase of our sharing. So, to recap, deep learning has revolutionized artificial intelligence by leveraging neural networks with multiple layers to extract intricate patterns. Its success stories include AI powered healthcare, weather forecasting, and virtual assistants. From the Culloch Pitts neuron model to modern advancements, deep learning has evolved to tackle complex real-life problems. With ongoing researches, deep learning will continue to transform industries, shaping a future driven by intelligent technology. Now, the Q&A session is open. Please do voice any inquiries or sharing based on our presentation today. The stage is open for any discussion. Thank you.